Good morning, everyone, and welcome to Monday, April 20th. We are going to focus on factoring some expressions that are called special cases. As our warm-up today, I want you to factor these two trinomials. The first one, n squared minus 3n minus 40. The second one, x squared plus 0x minus 9. Go ahead and pause the video, try them on your own first, and then unpause while we go over. So what you might notice with both of these is that they are trinomials, meaning three terms, and both of the expressions have a leading coefficient of 1, or that means there's no number out in front, which means we can use, of all the methods that we've learned for factoring trinomials, the one that applies here is the good old-fashioned P's and Q's. Now, feel free to pause at any moment and try it on your own now that we've talked about that. So what P's and Q's mean? P's and Q's means that I'm going to factor this in essentially one step. So I know my answer is going to be a product of two binomials. So I can almost set that up to begin with. I also know that the first term in each of my binomials is going to be the variable, because what times what is n squared? That's going to be n times n. And what times what is x squared? That's going to be x times x. So really, I'm 50% of the way done. I just have to figure out what the second term in each of the binomials is. To do that, I'm going to play the P's and Q's game. So just as a reminder, to play the P's and Q's game, we find two numbers that have a product of the last term. A product of the last term. Now here's the thing, there's a bunch of numbers that we could multiply together to get negative 40. So how do we know which one is correct? Is it negative 4 and 10? Is it 10, negative 10 and 4? Is it 8 and 5? Like, what is it, right? The way that we can tell is because those same two numbers have to have a sum of the middle term. So what I like to do, and some of you are pretty good at this now that you don't have to do this, but if you want to, you can always just put that math off to the side. So really, I'm trying to figure out what times what equals negative 40, that when I add them together, I get negative 3. So I'm thinking in my head, negative 4 and 10. Well, negative 4 plus 10 is 6. That's pretty far away from 3, so that didn't work. What about 8 and 5? Negative 8 and 5, negative 8 and 5. Yeah, negative 8 plus 5 is negative 3. So I know my two numbers are negative 8 and positive 5, excuse me, because negative 8 times 5 is negative 40, negative 8 plus 5 is negative 3. So what do we do with this information? Well, we now know what the second terms are going to be. We know the second term is going to be negative 8, so I read that as a minus 8 and positive 5. And I am now done factoring the first trinomial. Like, that's it, I'm done. I've taken a trinomial, I've written it as a product of two binomials. We're done here. We can do a quick mental check. N times n is n squared. Negative 8 times 5 is negative 40, and negative 8 plus 5 is negative 3. We're looking pretty good here. Over to the side, looking at number 2. Set it up. What two numbers have a product of negative 9? Now this one's a little bit weird because I made the sum 0, and I did that on purpose because of what we're going to look on later on. So what times what is negative 9? That when I add them together, I get 0. Now here's the thing, whenever you're trying to find a sum of 0, the two numbers have to be opposites of each other. For example, 2 and negative 2, 5 and negative 5, 6 and negative 6. That's really the only way in this particular instance that you're going to be able to add two numbers together to get 0. So that gives me a hint. Basically, what opposite numbers multiply to negative 9? What about 3 and negative 3? 3 times negative 3 is 9. 3 plus negative 3 is 0. Excuse me, is negative 9. I don't know if I said negative or not. So I found my two numbers. My two numbers are positive 3 and negative 3. Do a quick check. X times x is x squared. 3 times negative 3 is negative 9. And 3 plus negative 3 is 0. We are looking good. Okay. So once we've done that warm up, now we can actually get into the instructions. So these are called special cases when it comes to factoring. And the reason why they're called special cases is because the methods that we use to factor these expressions are slightly different than the methods that we've gone over so far. So this first special case is called a difference of two squares. Here's what it looks like, and then we'll go over why it's actually called a difference of two squares. So our first working example, example 1, is going to be x squared minus 36. Okay, why do we think this is called a difference of two squares? Well, the first thing that steps out or that stands out to me is, what is a difference? A difference means subtraction. Does this expression contain subtraction? Meaning, is this expression a difference? Yes, it is. So first of all, we can realize that it is a difference because you are subtracting. Now, the next thing it says is it tells us the number of terms, difference of two, difference of two terms. Is this a difference with two terms? Yes, it is. Now, what do you think that squares thing means? Maybe we'll come back to that a little bit later on. So it's a difference, it has two terms, and then later on when we look at a couple patterns, we'll talk about what the squares mean. So the first thing that I notice here is that it is a binomial. It has two terms, and normally when it comes to factoring a binomial, we would look for a GCF. So I ask myself, what's the greatest common factor of x squared and 36? There is none. So at this point, GCF factoring doesn't work. There isn't a GCF here. So you might be thinking like, okay, then it can't be factored. Well, that's actually not true. Here's the thing. What I notice is the first term is an x squared, and the last term is a constant. It's just a number. There's actually a term that's missing from this expression. And if you recall from our warm-up, that term is the x term. Notice how there's nothing with just x in the middle here. So what can we do? Well, there's a shortcut and then there's a longer way. I'm going to show you the longer way first, and then we'll talk about the shortcut. The first thing that we can do here is we can actually add in a placeholder 0. So we can do what's called a placeholder 0 term. So just like we did in our warm-up, we're just going to rewrite this expression with 3 terms with a placeholder in the middle. So it basically becomes x squared plus 0x and minus 36. If you think about it, adding 0 doesn't change anything to the actual expression, like its value. It just changes its number of terms. We could add a bunch of zeros if we wanted to. In this case, we're just adding that 0 term. Why do you think we did that? Well, if you recall in your warm-up, we were able to factor a 3-term trinomial with a 0 term in the middle. Basically, this now allows us to use P's and Q's. So now that it is a trinomial, we can factor using P's and Q's. And don't tell me you don't remember how to do that, because we just did it in the warm-up. So I'm going to set up our structure here. We know factoring with P's and Q's that my final answer is going to be a product of 2 binomials. The first term is going to be x in both, because x times x is how we get x squared. Now we have to find the other 2 terms. To do that, we play the game, the P's and Q's game. What 2 numbers have a sum of 0 and a product of negative 36. Now, if you remember from the warm-up, how do we get a sum of 0? We get a sum of 0 by adding opposite numbers, meaning same digit, but one of them is positive and one of them is negative. So that should basically help you figure out what your P's and Q's are going to be. So what 2 numbers multiply to negative 36 and add to 0? I think you figured it out. Those 2 numbers are positive 6 and negative 6. All right, so coming over here, we're going to make this one positive 6 and make this one negative 6, and dun da da da, we are done. I know, crazy, right? So now you're going to practice doing the same thing on the second working example. So this is example 2. And while you're working on the second example, I want you to see if maybe there's a pattern that shows up. Like look at our first warm up, look at our first example, look at our second example, and see if you see a pattern. So the one that you're going to do for me is x squared minus 81. X squared minus 81. So same steps, or if you notice a pattern, you might actually be able to jump straight to the answer, hint, hint. Go ahead and pause the video now and give it a shot. And here we go. Welcome back. Here we go. Step 1, placeholder 0. So we're going to take this 2-termed binomial and change it into a 3-termed trinomial. So my first term is still x squared, but I'm going to add in a placeholder 0x. And then my last term is still a negative 81. Now I play the P's and Q's game. Here's the thing. My sum is 0. My product is negative 81, which again means it's going to be the same number, one positive, one negative. We call those 0 pairs. Now I'm going to set up my answer here. My answer is going to be a product of 2 binomials. X times x is how you get x squared. So now I just need to find the sum and the product. So what times what is negative 81? Then when I add them together, I get 0. I'm thinking positive 9 and negative 9, or negative 9 and positive 9. The order doesn't matter. Come over here, first term negative 9, second term positive 9, and done. Again, this is the answer that we're looking at here. This product of 2 binomials. All right, pretty straightforward, right? Well, what if there was a way to get right from the original expression, bypass all of this and jump straight into the final answer? There is a way. That's why this is called a special case, because it's called a difference of 2 squares for a reason. What is a square? When I hear square, I think about the actual shape, right? An actual square. And what's fascinating about a square is that all 4 sides are the same. That means that the 2 sides of a square are the same number. For example, a 4 by 4 square or a 10 by 10 square. So when you take the area of that square, your answer is something called a perfect square. So when we say squares, we mean perfect squares, or numbers that could be the area of a square. So these numbers are numbers like 1, 4, 9, 16, 25, 36. You get the idea, right? So not only does this have to be a difference, meaning subtraction, of 2 terms, both terms have to be perfect squares. Was that the case? Let's see. Is x squared a perfect square? Could you have a square where both sides are x and x? Yeah, you can. That's a perfect square. Is 36 a perfect square? Can you have a square with an area of 36? Yeah, 6 times 6 is 36. Both of these are perfect squares. Let's look here. Is x squared a perfect square? We've already established that. Yeah, x times x is x squared. This is a perfect square. Is 81 a perfect square? Yeah, 9 by 9 would make a perfect square of 81. So not only are these differences, 2 terms, both of the terms are perfect squares. Why does that matter? Well, you might notice something here. The numbers that we found in our P's and Q's were not random. If you look, the numbers that we found, the positive 6 and the negative 6, why do you think those 2 numbers worked? Well, for those of you who found it, give yourselves a little pat on the back. Those 2 numbers worked because they were the square root of the second term. That's it. What's the square root of 36? Oh, look, 6 and 6. So to get the second term, you don't actually have to do all of this P's and Q's work. It's the square root of the second term. Well, how did we get the first term? Same thing. What's the square root of x squared? Oh yeah, x and x. Now, I hope some of you were like, but wait a minute, the square root of 36 is positive 6. So why isn't this a positive 6 and a positive 6? That's because this is a difference. It's subtraction. And that middle term has to add up to 0. And 6 plus 6 doesn't equal 0. Negative 6 plus negative 6 doesn't equal 0. So you're basically, the trick here, and this is what we're going to learn about, or the shortcut is, when you're given a difference of 2 squares, you can jump straight into the answer just by taking the square root of the first term and the square root of the second term. And dum-da-da-da, you will have your answer. So we're going to look at how to do or how to factor additional problems like this, difference of 2 squares, but this time we're going to use that pattern rather than going through the entire process of P's and Q's. And we're back. Okay, difference of 2 squares, examples 3 and 4. So for these examples, we're going to use the pattern that we just noted, which is, and you can kind of see it over here on my right-hand shoulder, if it's a difference of 2 terms and both terms are perfect squares, you don't have to go through the process of a placeholder 0 and P's and Q's. You can just take the square root of both terms. So our first example, let's do x squared minus 16. Okay, check 1, is it a difference? Yes. Check 2, does it have 2 terms? 1, 2. Yes. Check 3, are both terms perfect squares? Yes and yes. All right, ready? This means that our final answer, we can bypass all of that other work. Our final answer, oops, let me get a different color, is going to be a product of 2 binomials. I know, shocking, right? It's always a product of 2 binomials with these. So set that up first. One of them, actually, I'm not going to say that. Here we go. Product of 2 binomials. How do you find the first term? You find the first term by taking the square root of the first term. What times what is x squared? Oh, we know that. That's x and x. Now, you might be thinking to yourself, like, why are we taking the square root? We already know that. When you see the next example, you'll know why. So to find the first term, we take the square root of the first term. To find the second term, we take the square root of the second term. What's the square root of 16? Meaning what times what is 16? That's 4 and 4. Now, I've purposely taken out something because careful. These 2 numbers, remember that placeholder 0? There is a placeholder 0 in here. So how do you add 2 numbers and get them to add up to 0? One of them has to be positive. The other one has to be negative. Done. That's it. We're done. That's why we call this a special case. It's actually simpler to do than all the warm-up problems even. We're done. All we did was we took the square root of the first term, the square root of the second term, and then we made them a 0 pair by creating 1 positive and 1 negative. And you are done. Crazy, right? I know. This was example 3, by the way. It's that simple. Let's take a look at example 4. Now, this one I'm going to purposely do a little bit different, okay? Here we go. I'm going to do 9x squared minus 36. Yeah, I'm good with that. 9x squared minus 36. Okay, wait a minute. I put a 9 there. Did I mean to do that? Yes, I did. Okay, check 1. Is it a difference? Yes. If it's not a difference, can't do it. Check 2. Does it have 2 terms? 1, 2. Yes. Check 3. Are both of these terms perfect squares? Well, we know 36 is a perfect square. Is 9x squared a perfect square? Is 9 a perfect square? Yeah, 3 times 3. Is x squared a perfect square? Yeah, x times x. So we can do difference of 2 squares. So very quickly now, we get to set up our 2 binomials. And to find the first term, you take the square root of the first term. What times what is 9x squared? Well, what times what is 9? That'd be 3 and 3. And what times what is x squared? That'd be x and x. Okay, ready? What times what is 36? In other words, what's the square root of 36? That would be 6 and 6. But how do we get that 0 term in the middle? Because we can't make both of them positive, otherwise this doesn't work. How do we get the 0 term in the middle? You make one of them positive and one of them negative. Done. Okay. Now, some of you, I hope you're noticing this, so this actually could have a GCS taken out of it. And I'm glad that you did notice that. But for the sake of what we're talking about now, we're done. Like, that's all that you had to do. Amazing, right? I know, totally crazy. Okay, we're going to wrap things up with an exit ticket on difference of 2 squares. And yeah, get your pencils ready. All right. For our exit tickets, I want you to factor 16x squared minus 1 and 25x squared plus 49. To make sure that you're doing this correctly before we go over it, why don't you go ahead and multiply to check? Because I think you might see something weird with number 2 there. So go ahead and set that up. All right. Now, remember, it's called a difference of 2 squares for a reason. In fact, sometimes it's nice to write that down. It's a difference of 2 squares. This name basically gives you a checklist. It must be a difference, it must have 2 terms, and both terms must be perfect squares. So let's take a look at the first one. Is it a difference? Yes. Does it have 2 terms? Yes. Are both terms a perfect square? Well, let's think about that for a second. 16 definitely is, and x squared is also a perfect square. Meaning, if that square wasn't there, if the 2 wasn't there, 16x is not a perfect square. Like, you can't have a square where one of the sides has x and the other one doesn't. So that square is pretty important. You must have that square there. Is 1 a perfect square? Can you have a square with an area of 1? Yeah, a 1 by a 1 is an area of 1. The square root of 1 is 1, guys. So is this a difference of 2 squares? Yes, it is. So because of that, we can just set up our answer. All right, now, how do we find the numbers that go inside of the parentheses? Well, if you remember how difference of 2 squares works, look at your notes. You find the square root of the first term and the square root of the second term. So what is let's see if this pen works. Ooh, I like that. What is the square root of 16x squared? 4x. So our first term, I don't know if you can see that, yeah, is 4x. 4x times 4x is 16x squared. What's the square root of the second term? 1. So 1 times 1 is how you get 1. Now remember, the most important part of this is there is a hidden 0 term in here. So how do you don't add 1 and 1 and get 0. That doesn't make any sense. So make sure when you go back to do your final answer, you make one of them positive and one of them negative. Now, does it matter which one? No. This one could be negative and that one could be positive. That doesn't matter, but it must be one of them positive and one of them negative. Otherwise, you can't get that 0 term in the middle. And guess what? You are done. Boom, done. Yeah, pen drop, right? So let's take a look at number 2. Let's go through the checklist and make sure that it is a difference of 2 squares. Check 1, is it a difference? It's not a difference, it's a sum. This isn't called a sum of 2 squares. So if you saw something like this, guess what your answer would be? Not factorable. I got some of you, didn't I? Some of you tried to say that the answer was 5x plus 7 times 5x minus 7. Guess what? It has 2 terms and both terms are squares, but this is not a difference. So it actually can't be factored. But that's boring for an exit ticket. So you know what I'm going to do? I'm going to change this into a difference just so that we get that extra practice. Because I know you guys are probably dying for that extra practice. Okay. Now, is it a difference? Yes. Now, does it have 2 terms? Yes. Are both terms perfect squares? Because guess what? If this wasn't a perfect square, if that was like 5x, is 5 a perfect square? So could I use difference of 2 squares? It must satisfy all 3. It must be a difference. It must have 2 terms. Both terms must be squared. Let's make that a 25 again. All right, check, check, check. We know we can use difference of two squares. Here we go. All right, step one, take the square root of the first term. What is the square root of 25x squared? Meaning what times what is 25x squared? 5x times 5x. Yeah, 5x and 5x. 5x, 5x. All right, now take the square root of the second term. What times what is 49? 7 and 7, yes. So 7 and 7. All right, now remember the most important part of all of this is how do you get that middle term to be 0? One of them is positive. I'm going to flip it up this time. One of them is positive and one of them is negative. And dun da da da, you are done. I know it's crazy, but that's the cool part about difference of two squares, because that middle term is 0. You don't have to do P's and Q's factoring every single time. Or can you imagine trying to do slip and slide with a leading coefficient of 25? No, thank you, right? So use difference of two squares. If it's a difference, it has two terms and both terms are perfect squares, it's going to save you a whole bunch of time. All right, have fun factoring.